everyone, and welcome to today's webinar, Making Connections. My name is Trevor Spence, and I will be sharing with you DSM Engineering Plastics Material Solutions for connectors in consumer electronics. I work on the electrical and electronics team here at DSM Engineering Plastics, and I'm excited to share this presentation with you today. So I'm based in Cupertino, California, and I have 15 years of experience supporting high-performance engineering plastics, and I work with engineers, molders, and material specifiers in order to find the right material for demanding applications. A couple quick housekeeping items. We'd definitely like to hear from you during today's presentation. So if you have a question for me, please feel free to send it using the webinar's chat feature, and I'll be able to answer your questions by email after the webinar is completed. Also, after the webinar ends, a link to it will be shared with you by email, and you will be able to watch the webinar again on demand if you like, or you may also forward the webinar link to your colleagues that might have an interest in learning about DSM's material solutions for connectors. In this presentation, I will cover the market trends that are driving the usage of connectors, our materials offering for connectors, DSM's sustainability approach to the market, and some successful innovations with our materials for consumer electronics. Starting with the market overview and trends. So first, what we're seeing in the market is that consumers simply just want to be more connected. So at home, folks are becoming more connected with devices integrated into the home. Think digital assistants like Siri, Alexa, or a home hub, or devices like thermostats, security cameras, or smoke alarms that are used for safety, security, and entertainment. And consumers want ease of use and access to these devices, which brings us to the next point, being more mobile. Consumers just want to be more mobile and less tied to a desk or a specific location. And they want to have access on the go, and often with more functionality from the same device and with faster data transmission. So being more mobile means device size is a factor. You want to carry around a small mobile device, so often less space is acceptable for the increasing functionality from these devices. And it's important to note that while devices are trending toward wireless mobility, physical connections are still required. So for example, a physical connector is required for a wireless charging station. And the last point here is that consumers are having a greater environmental awareness, and companies are taking a proactive stance on environmental sustainability. USB-C, for example, having rotational symmetry, meaning that it can plug in either way, and it has the capability to eliminate the audio jack, power port, and HDMI connections. So essentially the USB-C is a combination of focusing on the user experience and also electronic waste reduction, where the single universal design of the USB-C connector can handle power and signal transfer for different devices, eliminating the need to always have a different cable for each device. And moreover, with organizations like EPEAT, which is the leading global eco-label for the IT sector that issues points on a merit-based system based on the eco level, manufacturers are motivated to use sustainable procurement options to reduce electronic waste. So these market trends are pushing for new kinds of connectors. So with the USB-C standard launched in 2016, we're finding the Type A and Type B connectors increase from 6 pins to 24 pins, which means a more condensed fit of pins into a smaller space, and the capability to replace the audio and power jacks, similar to the Lightning connector. And so as to not take up a large amount of real estate inside a mobile device, the connectors are designed to be small, but are still required to provide electrical insulation and at the same time offer mechanical support and durability for everyday use of plugging in and out. It goes without saying, but device safety is critical, and connectors need to resist fire or shorts from water, dust, sweat, or even things like pocket lint or other contaminations. And connectors need to withstand the processing and assembly steps, which can reach temperatures up to 260 degrees Celsius in the surface mount technology reflow soldering process, basically the standard soldering process of the industry, and other steps like insert or overmolding at high temperatures, or processes for aesthetic surface finishing like physical vapor deposition. And lastly, the color of the connector can be important for design teams to create a visually appealing device or to differentiate the type of connector. So what does this mean in terms of material properties? The materials need to be thermally stable to withstand reflow soldering, and they also need to maintain mechanical integrity to handle the impact and wear from tens of thousands of insertion cycles. The material needs to be able to be injection molded in order to make very thin walls with tight tolerances. Weld line strength retention of a material can also be really important for thin walls and small intricate parts so that the part doesn't break. And the material must allow for fast processing and short cycle times to manufacture millions of components. And this means that the material will need to be high flow. Safe and functional. Materials need to be safe for people and the environment, and at the same time provide electrical properties that are capable to handle fast data transfer speeds and high power without electrical tracking, and often need to be available in a wide range of colors. So moving on to the DSM materials portfolio for connectors in consumer electronics. Just a little background on the company. DSM Engineering Plastics is a high-performance materials solutions provider, offering materials that are high up on the polymer pyramid, which signifies increased performance for temperature resistance, chemical resistance, and mechanical strength. At DSM Engineering Plastics, we focus on semi-crystalline polymers, which in general tend to perform at higher temperatures. ECOPAXX PA410, STANYL PA46, FORTI PPA, and Zytron PPS, offered in the electronic space, are among the highest performing plastics that support designs covering the breadth of the connector industry. These industries include automotive connectors, appliance connectors, connectors for consumer electronics, like we're talking about today, connectors for data center networking, and medical connectors. This is a quick reference summary table listing the materials and key properties required for current and future connector applications in consumer electronics. So listing here are the materials in the portfolio that are capable for surface mount technology reflow soldering. Each can be color matched, they're halogen free, and are safe for use by resisting UL 94 rating. The eco column refers to the material having a biosourced raw material. And I should note that ECOPAXX, the material I'll talk about a little bit later, but it has the highest bio content. However, it does have a bit lower melting temperature that limits its use for reflow processing. But the temperature does withstand wave soldering. ECOPAXX has found success in wire-to-board connectors and installation in power adapters due to its low moisture absorption. And Zytron polyphenylene sulfide has been successful in flat printed connectors and flat flex connectors, FPCs and FFCs. Now, going a little deeper into the properties of STANYL PA46 that make it a popular choice for connectors. A feature that sets STANYL apart from other materials is its colorability at high temperatures. Color matching is important for, as we know, for sleek designs of smartphones, tablets, adapters, or other peripherals that we all use every day. And it can actually be difficult to match a specific LAB value, especially after going through the high temperature reflow process. The colorant can also impact flow and mechanical properties, so it's important to find the right balance between the color and the material specifications. Down below, I mentioned polycarbonate because it's often used as the benchmark material for colors because it can achieve very bright colors. But STANYL, which is a much higher temperature material, has been developed into a wide range of colors as well, including bright whites. And it's manufactured to match colors post-reflow. Also worth mentioning is that FORTI and ECOPAXX also have both good color stability. So as I've already mentioned, the thermomechanical properties are important in order to resist the high temperature reflow soldering process. And without going into detail, the 4-carbon or 4C technology in these polymers lends to higher crystallinity, which means that at elevated temperatures, the polymers can maintain their rigidity. And this is especially noticeable for STANYL, which is actually the highest crystalline aliphatic polyamide. And also for FORTI, it's a unique polyphthalamide PPA material, but each FORTI and STANYL have HDTs that are very close to their melting temperatures. In case you're not familiar, the heat deflection temperature, or HDT, is simply a practical test that measures the temperature at which a plastic bar bends under a specified load. Or I guess in other words, it's a measure of the stiffness of a material as the temperature rises. And the takeaway being that the HDT of material must be above the 260 degrees Celsius mark in order for the material to withstand the SMT reflow process. So STANYL, FORTI, and FORTI ACE all fall within that category. Metal pins of connectors can scratch the surface of plastic insulation and over time can wear and create a loose contact. And wear testing is a way to mimic the repeat use of in and out connectors to test the durability of the material. And here the image shows a comparison of halogen-free B0 low warpage grades. And in the test, a probe pin is loaded to 20 grams and rubbed along the surface, wearing away the material. And the high crystallinity of the STANYL base polymer gives it special wear resistance performance and the best wear resistance of the V0 grades in the test. You can also see here that FORTI performs very well. And for this reason, STANYL and FORTI are both used extensively in gear applications and in automotive parts like chain tensioners for its temperature and wear performance. In consumer electronics, connector designs can have walls less than 0.2 millimeters. I mean, these things are like paper thin. And this can cause problems at the motor trying to fill the part. And so therefore, a high flow material is required, and high flow STANYL is available for these types of applications. The plot here shows the flow length of STANYL at 3 different injection pressures, exhibiting our portfolio for 20%, 35%, and 45% glass filling, halogen-free V0 flame retardant materials. Comparing STANYL to PA6T, we show the shear thinning effect of STANYL, which contributes to a larger increase in flow length at the same injection pressure. Or as injection pressure is increased, the flow of the material of STANYL gets better. So this means faster fill, shorter cycle times, and greater productivity using STANYL PA46. So in small parts with thin walls, it's important to retain a strong weld line in order to prevent a weak spot where the flow fronts meet together. And the drawing here shows a tensile bar with a weld line in the center that gets pulled apart, and then the tensile stress gets measured. So basically, you're measuring the strength at the weld line of the material. And for LCP, weld line strength is recognized as being a known weakness in the industry, but STANYL and FORTI both have flow fronts that bond well to retain weld line strength. And this is important for parts that, especially when they're small and thin, so that they don't break easily at the weld line. A property that can be measured to ensure safe use of a device is the tracking resistance. Electrical tracking is defined as the formation of electrical pathways through the material that are caused by electrical stress, water, or other contamination. So as connectors get smaller and smaller and more pins are added, and these pins are required to handle higher power, tracking resistance becomes more and more important. So then the comparative tracking index is a way to measure the tracking resistance under wet and contaminated conditions. So in the test, a salt solution is dripped onto the surface between two electrodes with an applied voltage. The test rates the materials by the voltage potential they can withstand before tracking occurs. And STANYL and FORTI are both in the highest category for tracking resistance in the CTI test. Here we attempted a real-world CTI simulation with STANYL PA46 and LCP using droplets of a salt solution. These are USB-C receptacles. And as you can see in the picture on the right side, LCP could only withstand 12 droplets before significant burn marks were made, and it had electrical breakdown. On the left side is the STANYL receptacle that can withstand 60 droplets, and even then it had electrical corrosion, but no significant plastic structural damage was made to the material. So in practical terms, what this means is that STANYL will withstand higher contamination on the surface of the connector than the LCP material before tracking occurs. This is important in a USB-C connector because per the standard, the dimensions are set and cannot be changed. So the size of the connector stays the same. But what can be done is to use a safer material that has a higher CTI value like STANYL, which will ensure a safer device and component. In electrical data properties, the dielectric constant for STANYL is approximately 3.5 in the 10 gigahertz frequency range and remains stable as frequency increases. And stability is the key for designing today's connectors so that engineers can predict how the component will perform at high frequencies. What you notice is that the material is somewhat inherently hygroscopic because it is a polyamide, and the dielectric constant can increase with increasing moisture, also affecting the dissipation factor here. However, for extremely harsh conditions that have high humidity and high temperature, FORTI PPA will perform really well because it takes on little moisture. And at 10 gigahertz, it has a dielectric constant of around 3.8, and that's at 23 degrees Celsius and 50% humidity. The ability to seal smart devices from water or dust is a concern for manufacturers as well, and it can actually be really challenging. So there's different methods that can be used to create a seal that include sonic welding, laser welding, the use of adhesive or overmolding in order to seal the gap between the metal pins or metal shielding and the plastic housing. STANYL and FORTI can be used in these processes and have success with different ingress protection designs. Here you'll see in the bottom image is an example of a FORTI connector housing that when it's fully assembled, it can achieve an IPX8 rating, which basically this means that the device can be submerged in water to a specified depth greater than 1 meter without the water getting in. So moving on to FORTI in more detail, another SMT-capable connector material. So like STANYL, FORTI is based on 4C technology, but with terephthalic acid, offering the same high CTI rating and flame resistance, but it offers a higher modulus than STANYL. In the FORTI family are FORTI, FORTI Eco, and FORTI Ace. All grades withstand the processing temperatures of the SMT reflow soldering. The FORTI family can be generally described as polyamide with high mechanical properties and good chemical resistance. They maintain stable dielectric properties, and the connectors can be processed without concern of blistering from moisture because the material takes on very little moisture. FORTI Eco is manufactured in part from a biomonomer, and FORTI Ace has the highest melting temperature in the PPA family of polymers. This is an application slide exhibiting FORTI Eco in a USB-C connector. FORTI is typical on the plug side that needs higher strength than a receptacle, but it does have commercial success in both applications. Here, FORTI was chosen for use in the USB-C connector because of its rigidity, toughness, and resistance to wear. And FORTI Eco also has the benefit of having the partial bio content. Here, FORTI Ace, having the extreme thermal resistance and high modulus, was chosen for this automotive connector. The material has the highest JEDEC1 moisture sensitivity level rating, which means that it will not blister during the reflow soldering process, even in humid conditions. And in DDR connectors, FORTI is used because it meets the coplanarity requirements, which are tight, and it means that the surface of the connector has to be very flat so the connectors all touch the PCB. So here shows the success of FORTI in the DDR application, meeting these requirements. The crystallinity and modulus of the material also provides a high pin retention force, along with a strong weld line. And this is important where there are several ribs in the design of this connector. And then furthermore, the material can also be matched to a wide range of colors. So moving on to talk a little bit about the DSM's approach to sustainable materials. At DSM, sustainability is the core value of the company. The company sees tackling climate change as both a responsibility and a business opportunity, and so focuses on improving our own carbon footprint enabling the low carbon economy and advocating climate action. And here you can see achievable targets for the not so distant future for clean energy use and carbon footprint reduction. And this shows that the company is taking action. That brings me to our section on ECOPAXX PA 410. ECOPAXX is a material synthesized from two monomers, 1,4-diaminobutane that provides the 4-block and sebacic acid providing the 10-block. The sebacic acid is derived from castor oil, 100% of that oil coming from castor plants, and this results in roughly 71% bio content of the neat resin. Other benefits of ECOPAXX include that the material is carbon neutral from cradle to gate. The plants are a renewable resource, and they don't compete with the food chain. And the production is a source of global economic development. Okay, so the properties of ECOPAXX. Of the aliphatic nylons, ECOPAXX has the highest conditioned modulus. This is in part due to the low moisture absorption of the material, and it also contributes to having excellent dimensional stability in different environmental conditions, and contributes to the high electrical strength. ECOPAXX also has a high elongation at break, which makes it a tough material. So all around, the combination of properties make the material great for use in electronics. A couple of applications for ECOPAXX in consumer electronics. The power adapter is a success story where the incumbent material was changed to a high eco content material, being ECOPAXX. Lending to its success is its processability for thin walls, its high electrical strength, and flammability resistance. Also, its electrical strength made it capable for thinner walls than the incumbent material, so that the engineers could design a smaller component. Another application for ECOPAXX is in wire-to-board connectors. The material exhibits a high glow wire ignition test temperature. It's V0 rated, and it is thermally stable for wave soldering. All of these are key properties for this type of connector. And obviously, ECOPAXX has the added benefit of being a biopolymer. So before leaving the section on sustainability, I wanted to note that a life cycle assessment was completed for STANYL. It was compared to the same assessment for LCP. The study showed that STANYL has a 25% reduction in its carbon footprint. And we're always looking for ways to improve upon the carbon footprint of STANYL. Now I'll move on to touch on a few novel applications for these materials in other areas besides connectors, but still staying within the market of consumer electronics. So as you probably know, plastic is an insulator, so heat will accumulate in the material. Therefore, a thermoconductive grade of STANYL was developed to enable cooling compared to traditional plastics. And because it is a plastic, it reduces the weight compared to aluminum or other metals. Here we have a successful part that was developed for LED lighting. The plastic part is lighter than the aluminum part, or an aluminum part if it was made the same way. And it also provides a huge savings in CO2 emissions. A potential application for thermally conductive STANYL includes housings or battery casings in electric vehicles where heat needs to be drawn away from the battery and keep the battery cool. Laser direct structuring. This is a process that brings design flexibility It allows for components to be manufactured at a micro level and integrate directly into the device, the mobile device, and eliminate components on the printed circuit board. So this way you can have a smaller component within the device itself. Basically, the process, or in the process, a laser ablates and activates the polymer surface. And then the same area that was ablated can be chemically plated with copper, for example. An area where laser direct structuring has had proven success is in mobile phone antennas with FORTI LDS. And this is translatable for various kinds of antennas for TV, notebooks, wearables, speakers, or automotive. And with 5G devices coming online, laser direct structuring will have more and more importance in this type of application because one device will likely have several antennas in 5G. In consumer electronics, nanomolding technology is used to bond plastic to metal, often onto flat areas. NMT is increasingly important for weight reduction and making parts thinner. But it has importance because it allows plastic to be used in areas needed for signal transfer without electrical shielding. So plastic can be used in places where metal was once used, but without shielding the internal components. So in the process, metal is etched to make a porous surface, as you can see here on the right side of the screen. Then plastic is injection molded onto the surface, which fills in the pores and creates a mechanical bond. And with the use of the engineering plastics listed here, anodizing or physical vapor deposition can be used to finish the surrounding metal surfaces on a part already assembled with plastic and metal components. The branches in the plot show the material options for the finishing process. Arnite and Zytron are capable of withstanding the acid and anodizing aluminum. FORTI and FORTI ACE used to bond to stainless steel and can resist high temperatures for physical vapor deposition finishing. This table shows experimental data that exhibits high strength bonding is achievable with NMT. And it's just another illustration of the materials that can be used in the finishing process. The HDT listed here is important because the more thermally stable the material, the hotter the physical vapor deposition process can be. And this is important in order to create a strong coating on the metal adjacent to the plastic. So in other words, the hotter the PVD process, the better the coating. So you need a plastic material that can withstand those high temperatures. PVD temperatures can reach up to 280 degrees Celsius. And with the high HDT of FORTI and FORTI ACE, you can achieve that more durable finish on the metal because it withstands those extreme high temperatures. And in this slide, it's showing a lot, but it does summarize the NMT and physical vapor deposition metal surface finishing processes. FORTI has high bonding strength to the metal substrate. It allows for very high temperatures during the PVD process. It contributes to high modulus to the component or device. It has the ability to resist breaking if it's hit or dropped with its impact strength. And it can be color matched to meet a wide variety of colors, as you can see in the bottom image. So the slide takeaway here is that PVD is used to treat stainless steel surfaces. FORTI can adhere to these surfaces using the NMT process. And then it can withstand the high temperatures and actually the extreme temperatures with the PVD process in order to get a strong coating on the surface of the adjacent metal. This brings me toward the end of the presentation. And I just wanted to comment that DSM Engineering Plastics is a truly global company having research and technology operations on 4 continents. But we also have a strong local presence in order to support our customers around the world in various industries. So I urge you to reach out. You can reach me at trevor.spence@dsm.com. And I thank you for joining me today for DSM Engineering Plastics webinar about making connections. I hope you enjoyed the presentation. For more information about DSM Engineering Plastics and to access DSM white papers and blogs written by our subject matter experts, please visit dsm.com/plastics. For information on specific materials, please visit www.plasticsfinder.com and enjoy the rest of your day.